Okay, so this is 11.2, which we already started to look at. And it's about solving equations. And the basic problem, looks something like this. This I'm calling a one-step problem because one step and you're done. The only number to get rid of, we want to keep the x, that's the goal, get it alone, get rid of the 5, and it's a plus 5. So I'm doing it like this. I'm subtracting underneath. The book may subtract here and here. I don't, it's up to you. But 5 and minus 5 is 0. So this is x plus 0, which is x. And then that's your basic answer. Now, occasionally, they have a problem. Let's see if I can find one, where the start is not as good as it could be. So here's one, and I'm pulling it out of the textbook. And there's always the chance I did it already. But this, they would say solve. And they might say solve the equation. And it's because it has equal to here with something on each side. And so step 1 is always to see, could you simplify either side? And so on the left side, I'm seeing 1, 2, 3 terms. And 2 of them are like terms. They're both considered x terms, and so they need to be combined. So what we're thinking is the 2 are 3x for the first one, minus or subtract 2x. And so together, that makes 3 take away 2 is 1x. And you could say 1x, or you could say the way they do things, just x. Because x and 1x are the same thing. Now you can't throw away this subtract 2 or minus 2, so I'm just going to copy it there. Now I come over to the other side and I have 4 subtract 9, and you know that's going to be negative because you're taking away more than you had. And so the answer, 4 take away 9, you're really subtracting the 2, and subtracting the 2 is 5, but it's negative 5. Do you remember that from before?
Yes.
Okay, so this was simplify, getting each side as clean and good as possible. And then when I look at it, I forget the top row. It's as if it didn't exist, gone. And what I'm left with is this. This is a one-step problem. And so when we get to a one-step, just do the one step, whatever it takes to make the x all alone. And so what it takes is to get rid of a negative 2 or subtract 2. So I would say opposite would be add 2 on the left and add 2 on the right. And I'm literally putting that plus sign. So the minus 2 plus 2 is 0. And so this is x. And then this, I have to figure it out. Negative 5 plus 2, you're still on the negative side. That would be negative 3. Okay. And I'd say after all that, grab it and say, well, that's my answer. Now they had a funny one. And so I'm going to show you the funny one. I use letter A, who cares? Subtract 3/4 equals 5/8. Okay. So they just pushed you in 1 or 2 cases to fool around with fractions. But if you look at the structure of the problem, here's the variable, the missing number. It's subtract this. And so what I want to do to clean this side so that it only says A, that's my goal. A equals done. I want to add 3/4 to each side. So the minus 3/4 plus 3/4 is 0. And so this is left with a plus 0 is a. And what I would then have to do is combine these. And remember, when you add, you must have like things. So this applies to fractions. Like things boils down to common denominator. So the common denominator would be 8, because 8 would work for both of them. So this one just needs to be copied. It was perfectly good in 5/8. This one needs to be doubled. So 4 times 2 is 8, and 3 times 2 is 6. So if I put those together, I could add the numerators. 5 and 6 would be 11 over 8. Now, as far as I'm concerned, knowing the way they do things in algebra, this would be acceptable. Unless it's a word problem, which is about, how long is a certain thing, then you might make it 1. But it tends to be that they want the mixed number. And so if I look at your work and I see this, I'm going to give you full credit, even if the program doesn't. But 8 into 11 is 1, and there's 3 left over, 3/8. So as far as I'm concerned, both of those answers are totally fine. We want fractions reduced, but this is a different thing. This is making it a mixed number instead of an improper fraction. So don't panic just because you see a fraction, just deal with it in the exact same way. And there was one more. And I think, and again, I'm hoping some of this is review, or at least you're starting to see this. Okay, step 1. If you see a mess, clean it up. And I would call this a mess, wouldn't you? It's a mess. So we're going to clean it up. And so to clean it up, I'm seeing the parentheses. I can do this, So this is 4 times each one. So 4 times 2a, 4 times 2 is 8a. And then 4 times 3, or -3, would be minus 12. So this was plus, this was minus. And so plus times a minus would be a minus. I'm going to copy the minus 7a. Okay. Over here, I've got almost identical to what I had before. I've got 2 subtract 5. These are 2 terms, but they're like terms. They're both plain numbers. So I want to make that as simple as possible. And 2 take away 5, what is it?
-3.
Good enough. -3. So my right side is perfect. My left side needs improvement. This is identical to the last problem, where I have 1, 2, 3. Notice how I even put little spaces between the 3 terms. It's just out of habit. The book might have them all in a row, but I tend to space them so I can see that's the first, that's the second, that's the third. But 8a subtract 7a are like terms, and you can combine them. How much?
1a.
1a. And then I can't throw that away. I have to just copy it. -12 is -3. So a mess became less of a mess, became a one-step problem. And when you get to this level, you're almost there. Your goal is to get a alone on the side, whatever side it's on. And so I'm going to add 12 and add 12, plus 12 both sides. The minus plus 12 is history, and we're left with a equals. -3 plus 12 is the same as 12 and -3. Answer?
No.
Correct. So see how we methodically did this, and there actually is, let's see. Okay, so in this section, they don't deal with it. Oh, no, they don't. So is anybody worried about left or right? It depends on how you were taught. I'm going to do this just to talk about it. Okay. I can look and see most of your faces and know that you're younger. And so it depends on when you were in school and when they tried to teach this to you. But at one point in time, they always loved the variable to be on the left. And so people were taught the X or the A or whatever it is needs to be on the left side. But the truth of the matter, it doesn't. And so in this particular problem, here's the equal to, the letters are on the right side. This does not affect anything. So what I'm going to do is simplify, take this mess and clean it up a bit. 8 take away 5, that would just be
3.
3. On the right side, so that's as good as that's going to get. On the right side, what I noticed is I see 3 terms, but 2 of them are like, they're both X terms, so they go together. 3X take away 2X would be 1X or just X, and then I don't throw that away, I say plus 4. Now, if you were taught that the X belongs on the left, this is looking out of whack. Is there anybody that's bothered by the X over on the right side?
No.
Admit it now. Nobody said it. This tells me a lot. So
No, I'm
this is
bothered.
good. What?
I would put the X on the left side.
You would. So it depends on who taught you. But
Yeah.
see, this is looking, it's almost like it's out of balance.
Uh,
And so if that's the case, I would say pivot these 2.
okay.
And so if that was the case, and I'm going to do this for whoever spoke up, thank you. X plus 4 equals 3. Do you see I didn't change a thing? I just pivoted. And there's actually a mathematical principle that says that's okay, you know?
Mhm.
And so the 3, and then what you would do is then it would look right to you and you'd see the one number that has to be removed is plus 4. So I would subtract 4 from each side. And the plus minus goes to 0. And this is left X equals, and 3 take away 4, you're in the negative zone here. What is it? -1, isn't it? But if that doesn't bother you, then, so that's the solution for the one that was taught that way, because it's going to, you know, bother you. But if it doesn't bother you, then what we're going to do is look at it like this. The X is on the right. So this is what we need to focus our attention to. And so X plus 4 is on the right. And so to get X alone, I have got to subtract 4 that side and subtract 4 that side. So 3 take away 4 is again -1. Here's my equal. The 4 -4 is gone, and I'm left with plain old X. So what I have is -1 is X, which is also X is -1. This is the same answer. Now, if they want it a certain way when you do your homework, then give it to them the way they want. But this is acceptable just as this is acceptable. And so I just wanted to remind you, in case somebody was bothered by that you can just switch the sides right off the bat as soon as you clean everything up. I would clean everything up first, because you need to see, well, which side is the letter on? And in our case, the letter was on the right. So when you see that, if it bothers you, just flip the order and go from there. Now, Most of you know what to do with this. So this is going into 11.3. And it makes sense for us to do it a little bit of this. You have seen this before. This means 4 times x. And the multiplication is understood when there's a number and a letter. It's understood to be multiply. And so the opposite would be divide. Both sides by the exact same number. And 4 divided by 4 is 1. And 1x is x. And we get our answer over here. 20 divided by 4 is 5. Okay.
I have a question.
Yes.
If we were to do that, but we knew obviously that 4 times 5 equals 20, would
We
that
go
count if you
straight to
just,
the answer?
yeah,
Well, there's no problem with going straight to the answer until I give you this problem.
hmm,
Saying?
Now that's a mess.
See what I'm saying? The reason I'm showing you what to do is because not all things work out lovely. And so what you'd say is, okay, the 4 is multiplied by the x. Take the same exact approach each time. It's almost like a broken record, just same. And so I'm going to divide by 4 and I'm going to divide by 4, like it or not. 4 over 4, 1x. And my answer here is 19 over 4. Will I accept that? I
no,
would. Or the other version would be to make it a mixed number. 4 into 19 is 4, because 4 times 4 is 16. There's 3 left over,
3.
4s. Both of those are good. But you see how there was a problem? See, I started, and you know you've seen this. I start out with the one that you can get regardless of how I do it. But then as soon as that's over, there's another one that you had to follow the plan, because there was no way to know
But you
that.
can kind of tell, when you get to it. I mean,
That's right. And so, I mean, that's what that's definitely what I wanted you to do. I want to do this one. Now, this one also could be guessed. Mhm. But on the other hand, we want to have a procedure when it doesn't go well by guessing. And so in this particular case, x divided by 5, instead of dividing by 5, I'm going to multiply by 5 on both sides. Probably would help if I switch colors so you can see what I just did. And then the 5 and the 5 cancel. And you're left with 1x. And over here, you have 15. So you can see from the beginning, 15 divided by 5 would be 3 when you put the actual number in place into the original problem. That was the correct answer. Now, I wanted to show you something that's also a fraction. Now, the 1/2 is multiplied to x. And our job is to get rid of the 1/2. Now, dividing by 1/2 is not the best plan, because then you're going to have dividing by 1/2 over here. But there is another way, and you may have figured it out from the previous example. The opposite of 1/2 multiplied by 1/2 is to multiply by 2. Now, let me just put that there and see if you see why that worked. I multiplied this side by 2, or what amounted to 2 over 1, do you see how that would cancel?
Yes.
But the minute I multiply the left, I'm going to switch colors just to show you I can.
Right.
So when I multiplied this side by 2, I then had to multiply this side by 2. And so the 2 and the 2 canceled. And I'm left with 1x, which is x, and 8 times 2 is 16. So multiplying by what amounts to the reciprocal, instead of multiplying by a half, I multiplied by 2, and that canceled out the 2's. That might be your very best approach for that. Although this was guessable as well. A half of my answer is 8. That was the original problem. A half of my mystery number was 8. That made my mystery number 16. Right? But they're not all that great. I wanted to do one with a negative. Sometimes this bothers people. -3. Oh, no, I don't want to do this. I don't want to do that one, but I will in 1 second. The first thing I want to do is this. 2x plus 1 is 9. I want to do that first. This is what I referred to, and this is not in any book. Well, maybe it is, who knows?
Two-step.
Two-step. Here, the left side has the x. There's the 2 to get rid of, and there's the +1 to get rid of. And you have to do 2 steps, or this will not be done. The whole goal is to get it to say x equals answer. And so you have to remove both of these. But removing the 2 first is a bad plan because you do it by dividing, which then forces you into a problem that was half decent into a problem with loads of fractions. And you know how we feel about fractions, right?
Ada.
So we do not want to do that. So with the 2-step, the first one is remove the single number. And the single number is this one. Do this first. And so not the number multiplied to the x, but the number that's a constant, or this, I call it a single number. So +1, I'm going to go -1 over here, on the other side, -1. This leaves me with 2x on the left. This is gone. On the right, 9 take away 1 would be 8. I am now down to 1 step. This was 2. Now it's down to 1. It keeps improving with every line. What do I need to do to both sides to finish this off?
Multiply.
This is multiply, so what do I do?
Divide by 2.
Oh,
Divide by 2. Exactly it, exactly. You get so used to this. We did this a little bit once in an earlier chapter, but this is the 2's cancel and you're left with 1x, which is x, and 8 divided by 2 is 4. So when you have a 2-step problem, and this has got to be an 11-3, when you have a 2-step problem, you want to make sure that you do this single number first. So what I did was I was drawn to the side that had the x. In this case, it was on the left. And so I said, I got to get rid of the 2. I got to get rid of the 1. What do I do first? The order matters so that you don't have a messy, messy, terrible problem. And so this, not that you couldn't survive it, but it's not a good plan to make things harder than it needs to be. So I went with a +1 by subtracting 1 on each side. And once I had done that, I then had a nice little 1-step problem, which is getting easier and easier to do. I saved this. This is the same thing. It's just not as cute as the last one. I made up the last one, by the way. This one I pulled out of a book. What number, here's my X, this is the side that has the X. What number has to come first or get rid of first?
7.
The 7 it is. And so because it's a +7, I will subtract 7 here and subtract 7 here. Well, that's gone. I am left with this term, and this term is -3x. Okay? Over here, I've got to completely combine these. And so this is negative, negative. And so first I'm at -5, and then there's more negative. So what is my final result of -5 and -7?
-12.
Correct. This is why I need to see your work. Because if I see that you did this first, then I'm happy. Because I'm seeing now you remember it was a 2-step, you remember to do this first, you successfully got to the next line. This is a 1-step problem. There's only 1 step left. But this X is multiplied by -3. The real question is, what do I divide by?
-3.
I'm going to put the 3 down, but the 3 is wrong because a negative and a
Positive.
positive would be negative. When you have a negative number multiplied to your X, you have got to divide by the number and the sign so that the 2 negatives will come out positive 1x. So this is critical because people say, oh, I see the 3, I'll divide by 3. No, 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 no. You want a -3 divided by a -3 so that it's positive. And then over here, -12, your choice was divide by -3. The -3 over -3 hits the dust and you're left with X. You're left with 1x, which is X. And over here, you try to remember the rule. The rule was a negative divided by a negative, 2 negatives make it
Positive.
positive what?
4.
Correct. People make mistakes here. And so, but try to, photograph that in your brain. You need to divide by -3, not just 3. And so that's what that's about. Now, I'm going to continue for the next couple of classes to go over this solving equations, because guess what's going to be in the algebra course? Solving equations. That's what they want you to know how to do. And so every little bit, every scrap that you can get from this course will serve you well in the next course. And I wanted to do one more. Let's see if I can find one that's not too bad. Here it is. 5x plus 3 equals 2x minus 3. I will teach this again on Friday. But this, if I teach this, then I can show you the complete look of solving equations. So I want to finish this last step. What's terribly wrong with this problem is this side is as simple as possible. That's 5x, one term. That's plus 3, no problem. This side is 2x, and then subtract 3 or minus 3. It's simplified as you can, each side, the left and the right side, are as good as you can get. But there's a major, major problem with this equation. And the problem is that there's 5x on the left and there's 2x on the right side. And until that's resolved, this problem is going nowhere. Because remember, the goal is to get X on one side, right? And the answer on the other, just like I had, like right here, I'll pull this out on the last problem. I was done when I said X on one side, 4 on the other. And then we were happy. But this is not going to work because I have letters on both sides. They're both X or we wouldn't be able to do it. So what I'm going to suggest is once each side is as simple as possible, and I'm going to write this all out, you move the X's to the same side, and I don't care which side it is, but get them together. I go after the smaller one. And so I'll write this out for you. This is 5X and this is 2X. I would go after this one. And so I have to take this as plus because there's no sign there to say minus. So I take this as a plus, and so to remove it, I would have to subtract. Okay? And I would have to subtract. So the 2X and the minus 2X are gone, and the only thing left is the -3 or -3. On this right side, 5X take away 2X is, I got too many threes here, 3X. I'm copying the +3. I don't like, yeah. So the 5X take away 2X is 3X. I copied the 3 and I brought down the -3. I have too many threes. Whatever I ask you to do, the answer is something to do with 3. This is a 2-step. I've got the 3 next to the X, which is together, and I've got the +3, and I've got that. What 3 do I deal with next?
+3.
Yes, indeed. This is the single number. This is a 2-step problem that needs this number and this number. I need to remove this one. And so because it says plus, I'm going to subtract, and I'm going to subtract. I do the same thing on each side to keep it in balance. That takes care of that. This leaves me with 3X on the left, and I have to put these two together. A -3 and another -3 makes
Let's see,
-6.
-6.
We've taken this mess of a problem and turned it into, now it's a 1-step problem. It is not done until you have X alone. But now it's multiplied by 3. So what do? Instead of multiply, we divide. And this was a +3, so I divided by a +3, and I divide by a +3 over here. So the 3's cancel. That's a 1X, which is X. And the answer appears here. 1 negative and 1 positive in division makes it,
3.
Positive,
makes it what?
Oh,
positive,
A negative. It's a -2. When you divide, when there's 2 negatives, negative divided by negative, that's positive.
Oh.
But negative divided by positive is negative. So 1 negative makes it negative. That problem is done. This particular problem used 4 steps. Well, actually only 3. They mention it in the last section, but I want you to have this. Solving equations. Okay, we may improve on this, but this is our list. Simplify each side. The left side, the right side. That could mean you might remove the parentheses by distributing. You might combine like terms. You know, we did that. in some of these problems, let's see. When we had two things that could be combined. So this is the cleanup step. Once everything is good, the next step is get your variables. And that's basically your letters on one side only. And that's the step I just showed you, getting the letters on the same side. So for instance, if I had 5x plus 1 equals 3x plus 2, I would subtract 3x from each side at that point to get the letters to one side. And I would move the smaller one. It makes it just a little bit easier because then you avoid negatives. Okay. The third step is when you're forced to look at a two-step problem. And so here's an example. 4x plus 1 equals 9. When you see the side that has your letter, and you see that there's two things that have to come off, the number multiplied maybe and the number added or subtracted, move the single number first. And in our case, I should have left more room. I would have subtracted 1 from each side. I would have gone after that. Kind of didn't have a lot of room. I would do that first. And to finish this off, when you have a one-step problem, for instance, 3x equals 10, basically do the opposite to get the x alone. Or it could be any other letter, but in this case it was x. So in this case, you would divide both sides by 3. This, we could improve this a little bit, but this is basically the sequence. And just so that you know, whoops, this is, I like people to know words. This is an algorithm. 1, 2, 3, 4. A lot of things have to be done in the correct order. And if you don't do them in the correct order, then you're making more work for yourself. An algorithm is a step-by-step approach to doing something. So, you know, you've seen that in other ways. But here's something I know. Go into it. This is a crazy example. Somebody's having a heart attack. I remember seeing on the wall 17 steps. And it was an algorithm. And the reason it was in 1, 2, 3 up to 17, the reason was because you want to correct it as quickly as possible. You don't want to go the long road, the slow road to China. You want to do it as quickly as possible to stop it or to remedy it or you know, resolve it. And so it was on the wall, 17 steps. I tell you that, I know that for a fact. And so that was an algorithm. And so you would do step 1, and then if that was the case, you'd go to step 2. Now, if for some reason you didn't have this didn't apply, then you just go to the next step. And see, this would quickly resolve the thing. Have you heard that word before? Algorithm?
Mm-hmm.
It's used in mathematics, but it's used in all kinds of things, doing things in the correct order. I'm sure, not that I cook, but doing things in the correct order sometimes simplifies things. What do you say? Do you say to that? this is the correct order to make it as straightforward as possible. And I wanted you to see that. So now, I know I haven't completely done everything, but I want to go over to, let me see. Someone asked about something in the homework, and I think we probably could tackle it at this point. Does anybody have anything else while I'm? Not interesting. There it is. Okay, 14 and 15. Okay. Okay, while I'm here, I hope you can see this.
Mhm.
These two sections are due today. Use a late pass. I think I added late passes. If not, send me a message and I'll add some more. So that's what we're doing. We're going to take a peek at 11.4. Just a reminder, in case you haven't realized this, this is finals week, the 14th through the 16th is what the school is doing. They set our final at 8 to 10 on Tuesday, which is different. So we will have a class on Friday and a class on Monday, and then we'll meet on Tuesday. So if that's an issue, that's the official time. So I'm not making that up. So let's see if
So it's 8 to 10 on Tuesday.
on
Just the
Tuesday,
test.
8 a.m. is the final. So
Oh,
yeah.
great. Thank you.
Yes. So I don't know, I'm gonna look at 11.4 and let's see if there's any way I can explain it at this point. Oh, geez. Was this the problem, whoever asked?
Yes, that's the one.
All right, let's see. Solve for X, I don't know, oh, okay. So the problem here, of course, is fractions, pretty much. But we're gonna try to stay calm. So everybody calm?
Mhm.
Okie dokie. Okay, in 2000, one share of Yahoo was, I'm going to write it down on my paper and I'll show you if I have to,
They gave you the equation.
177 and 1/8 at the beginning of the week, and it went to 183 and a quarter at the end of the week. Okay, so that's one sentence and it kind of tells you what it's about. It's about the price of the stock. But then the second sentence tells you what they want you to do, doesn't it? Solving the equation. And so it's 177 and 1/8 plus X equals 183 and a quarter. What are they actually trying to find with this equation? It was 177.
How much it
roughly speaking,
increased.
and it went to 180. They want to see how much it went up, don't they?
Mhm.
X is the yield, which is the increase, they said.
Mhm.
So really they're making an equation, but they really just want you to see how much it went up. And so once you get it, you'll find out how much it went up. So once we find how much it up, then the second part was, if you had this many shares, how much did your investment go up? Well, we'll deal with that in a second. So did everybody see what needs to happen? So let me, we had to deal with a stupid fraction. That was the equation. This is a one-step problem. X is over here. This is considered plus because there's no negative to it. And so this is plus, I've got to subtract this from both sides. And when I do that, that's gone. And this is X. And if I could just do this subtraction, I'll have my answer. Won't I? Now, the problem is that they don't have common denominators, and we could make this common denominator very easily. In fact, this needs to be into 8, right? And so if you double it both places, you would get 2 8s. So I'm going to write it down, 183 and 2 8s. Why? Because I'm subtracting and you need like things, which means you need common denominators. Subtract 177 and 1/8. 2 take away 1 is 1/8. I don't know why they did this. And 83 take away 77 is 6. Right? So it went up. That's the first answer, 6 and 1/8. And then the second answer was, and I remember it. So this was part A or whatever. That was the answer to that one. But part B said you had 240 shares. So each one of those went up 6 and 1/8. So you're getting this is really $6 and change. $6 times 240.
Uh-oh.
So the question is, do you remember how to do a whole number times a mixed number and get an answer? And so I would go 240 over 1. I would go 48 and 1 is 49 over 8. Now, if you pull out a calculator, I'm not going to fault you, but the truth of the matter is this 8 would go into 240, making it a lot smaller, which I like. 8 goes into 8 once, 8 into 24 goes 3, and then the 0. So it went 30 times. So then the final answer was 30 times 49. 1470. As far as I can tell, if I still have enough caffeine in me. What do you say?
Yep.
Huh. All right. So do you understand about that? So if you just had one stock, you would have that would have been what you would have gotten. But you had 240 of them, 240 shares. So each share went up 6 1/8. And so this is actually dollars. It went up that much. But they're trying to talk about, you know what they're trying to do. They're trying to talk about like what happens with certain stocks that go crazy. All right. This is how you would average grades. 71. This person, Justin, got 71, 85, 80, and 82 on 4 of the exams. The final counts twice. So if it had only counted once, I would have just put an X there for the missing final, but it counts twice. So they gave you the equation. And so it's all of that divided by 6 equals 80. They wanted to make sure he got at least a grade of 80. And so what you do with this is you add up every last bit that, in other words, you simplify everything you can simplify. 71, and I'm on my calculator, 85, 80, 82. So those numbers add to be 318. Is that what you got?
Yeah.
318 plus 2x divided by 6 is 80. Okay. So I'm getting out of this. I'm showing you what I'm going to do.
What happened?
Did you see what? So what I did was the 4 numbers, the previous 4 tests, I added it up because step 1 is always to make it as simple as possible. And so I did that. And so those 4 numbers added to 318. I copied the plus 2x and I copied the rest of it. Now the x is over here on the left side, but the dividing by 6 is actually the biggest problem we have. And if we could get rid of the fraction, that life would be good. So this is dividing by 6. And so if I took that entire side and instead of dividing by 6, I multiplied by 6. And I would be forced to do it to both sides. Do you see how great that would be? The 6s would go. So that you couldn't really get to the 2x until you got past this divide by 6. And so I multiplied by 6, and that's really doing the opposite. Cancel, cancel. So that leaves me with 318
Plus 2.
plus 2x. And because the minute you do something on this side, run over here. I mean, run. Did you see me run? Because I've seen people, well, I did it over here, but I'm going to go get a cup of coffee. And then I'm going to take my time getting over here. Once you do it over here right away. No, don't even think twice, because I've seen that mistake. So this is 80 times 6, 480. Now forget the mess up here. This is where we're at. This is a 2-step.
18.
The x times the 2 and the 318, which is a positive. This is a 2-step problem. And what did you do first?
Get rid of the 318.
318 is our target. We're going after it. I see it as positive because there's no negative to it. And so I'm going to have to subtract or minus 318 both sides. Gone. I'm left with 2x. And over here, 480 take away 318. This would be a 2. This would be a 6.
160.
I'm getting 162. See if you like it. You like it?
Yep.
Divide, divide. Cancel. X is 81. What that person needs to get the final average to be 80 is a score of 81 on that last test. And see how this might be useful to people to know what do you need to get what you need. Okay, how is that? So I think that the first step of simplifying was important, because otherwise you have so many numbers swimming around. You want to clean it up as soon as you see that you can. And then you cancel your 6. And I'm starting to hear people